All right, so Deep, it's been a while.
We're live.
Of course we're live. Now I'm not editing that, so you can. Let's get going.
Well, I hope you guys are doing well. Yeah, it's not been that long.
Yeah, it's been a couple weeks.
Yeah, it's been a couple weeks.
We really,
Over here, it feels like years.
True. Really busy.
Sorry, moves at light speed.
Cool.
Yeah.
So we talked about meeting more of the developers rather than just doing the hey, how are you, nice to meet you.
Yep.
Where we're going to dig into stuff.
Yes, we're gonna go deep.
So what are we going to do?
So here we are today with a special guest. I'll allow you to introduce yourself.
I'm Preetha. I'm a developer in Service Fabric team, and I work on the store part of Reliable Collections.
So we're gonna dig deep into reliable collections, and for those of you that don't know what it is, it's sort of our way to allow you to write statefully aware applications and store data and co-locate that along with your compute, and for us to be able to say, hey, yes, that data will be there, it'll be persisted correctly across all of your machines, and replicate in a way that we can then say it's resilient, it's durable, and has availability to the level that you need. So we're here with Preetha today to dig into that, and as she mentioned, specifically a little bit more into the transaction store that lies underneath that. But to start out with, could you give us a little bit of an introduction to reliable collections, a little bit more in depth than the one sentence that I had?
Yeah, briefly about Reliable Collections, and then we can go into in-depth into the backing store. So Reliable Collections is a distributed collections, and it supports user-defined data types. So just like how you create collections with custom types in Java or C#, you could create those types and you can put them in Reliable Collections. So our goal was to be able to help the customers build like integrated application types so that they could use us just like any other collection.
Sure.
And in the background, we would be replicating, persisting, and make it available for them.
Right.
And the other thing is Reliable Collections. You can create different kinds of collections and Reliable Collections. The ones that we ship out of the box are Reliable Dictionary, Reliable Q, and Concurrent Q.
Yeah.
And when the user creates transactions, they can create transactions that work across these collections. So there we give them all the consistency guarantees and things like that.
So how different is it, to use a reliable dictionary that you would have given me versus any other dictionary that I would have as a data structure generically if I were to write something in C or in Java?
Like in memory, you're saying?
Yeah.
So they're all going to be in memory data structures.
Okay.
And in terms of programmability, we are trying to be very close to those APIs as like C# dictionary or hash table in Java.
Cool.
And in the background, like I said, we'll replicate and do persist and do.
And they're called iReliable dictionaries, right? Is that the data type?
iReliable dictionary is the interface. Yeah.
So the goal is basically, if I were to write a program today that used a dictionary in some way, if I were to change that particular data type for that dictionary variable to an iReliable dictionary, almost it would work great on Service Fabric. With a few tweaks here and there, and all of a sudden now I get a huge amount of like resiliency and reliability from the platform itself.
Of course, you'll have to provide your serializers and I mean compilers you anyway provide even for the in-memory one.
Okay.
For this, you'll have to provide serializers as well. Yeah.
So and what's the difference between the queue and the concurrent queue?
So Q is a FIFO queue.
Yeah.
So you wanted it to be like in the traditional sense of a queue.
Yeah, the generic type. Yeah.
And the concurrent queue is more about people are not going to be happy with just FIFO queue where it's not going to be super fast. So for a lot of customers, queue is more about like eventing or streaming.
Right.
They really don't care about the exact order. So then that's when we said we'll have concurrent queue.
Nice. Okay.
And the Reliable Dictionary and Reliable Queue is backed by the same backing store, and the concurrent queue has its own native implementation.
Okay. So let's talk a little bit more about how we're able to make these things possible.
Okay.
So what happens under the hood when a user decides to use a reliable dictionary, a reliable queue that we're supplying? What are the components under the hood a little bit, and then how do they work together?
Okay. So there are multiple layers underneath. From the top, if you will, it's the store. I just call it the backing store.
Okay.
Or the T store.
Right.
As it is in the code. And then it's the state manager.
Sure.
And then the transaction replicator or the logging replicator.
Okay.
And then it is the log layer.
So walk me through what happens.
So these are the internal basic components, but on the top for the public APIs and stuff, we have other layers.
Sure.
And that layer is called Reliable State Manager.
Okay.
But in terms of depth, I think these 4 layers would make sense. So I'm going to stay away from the
Sounds
public
good.
layers.
That sounds good. So suppose I have an implementation for a reliable dictionary. I'm going to put in my first piece of data there. Can you walk me through how that goes through those layers?
Sure.
Yeah.
So
Can I use the whiteboard?
Yeah. So I can like start with the store a little bit and then go. So that way I'm not, so that I can stop at the different layers, and then
Sure.
when you do deep dive into the different layers, then you can talk about those as well.
Sounds good.
So the store is a distributed key value store. That's the one that backs Reliable Dictionary and the Reliable Q. And of course, it supports user-defined types. That's why they are able to support the user-defined types. And the second most important thing for the store is in general, it's for reliable collections as a whole, not just for the store. That is, we are a strongly consistent store. And next is about latency, like what you specified in terms of the co-location,
Yeah.
the user service running in the same process and the node, same node, same process as reliable collections. You're going to save on network hops, on reads and writes.
Right.
So let me go into reads a little bit, and then we can go into
Cool.
reads.
Yeah, sounds good.
So for reads, we support strongly consistent reads, and you can read from the primary replica or from the secondary replicas.
So why are they called strongly consistent?
Strongly consistent in the sense whatever data. So I'm trying to distinguish from eventual consistency and others that is being
Sure.
described. So strongly consistent means whatever you put in, you're going to be able to read that data.
Okay.
So it's not like we commit an ACK and tell you that we have written the data, and then we come back and tell you,
Just
like,
kidding.
no, you can't read
Yeah,
that
yeah.
data.
Yeah.
That's the layman terms.
Okay.
And so from the primary, you're going to get consistent reads, and on the secondaries, you could still read from secondary replicas, but the data could be stale, or we could give you data that could potentially roll back, which we call as false progress.
Yeah.
So it's basically non-quorum committed data that you could read from the secondaries.
Non-quorum, sorry, what?
Non-quorum committed
I see,
data
okay.
you could read from the secondaries. And in terms of isolation levels, which is going back to the consistency and all that stuff.
Right.
The store supports repeatable read. I don't know if I should write. but-
Yeah, well,
It's
you have to
fine.
write those words, yeah, but maybe we'll get a diagram when you, yeah.
So repeatable read, read committed, and snapshot isolation.
Okay.
Those are 3 isolation levels that are supported at the store.
Okay. So
And you
what are the
can change
differences?
and set to whatever you want. And these have like the traditional meaning of the same as the traditional isolation level
Okay.
meanings. I can go over it in detail or.
A little bit of detail, maybe.
Okay.
Yeah.
So read committed is basically you're able to read the data as soon as it is committed. So if there is when you're reading, there could be another change that is in flight.
Okay.
And repeatable read is like kind of isolation level where it gives you an illusion where you're the only one who is reading it.
Yeah.
So even if there's something going on concurrently, we'll protect it with locks. So what you get is what is there. So nobody can be updating behind your back. That's the repeatable read mode. And snapshot again means so you have your own snapshot of the data that you're going to read.
Yeah.
So things could be happening in the background,
yeah.
but we will keep
One snapshot of
a
it.
snapshot for you to keep going. Yeah.
Okay.
So this
Cool.
is the brief
Yeah.
introduction to the reads, and then so the other thing with reads that is important to be noted is that we maintain hot secondaries. So we deserialize your data and we keep it in memory.
Yeah.
So which means you save on the deserialization cost as well, as opposed to the traditional databases that you put in whatever format like they support, which is the standard data types they expose or byte array or whatever that is. On reads, then you will have to deserialize that in your app layer.
Sure.
So here we will have the objects cached basically for you, and you can read it directly.
Cool.
So if it is present in memory, you're going to get it from memory. If it is in the cache, otherwise you're going to have to do it's going to be a local disk fetch. But nevertheless, it's going to be a local read.
Yeah, not something that requires a network hop. Yeah.
Correct. With a network hop, yes.
Cool.
And
Yeah, so let's walk through what happens if, I'm putting something into the dictionary.
Right, okay.
Yeah.
so from the, let me go just through the store layers. So this is, all of these steps are going to be from the store layer.
Okay.
Can you write a little bit larger, your font?
I see.
Increase font.
Increase font size. Yeah. Unfortunately, we can't like select all and drag or anything of the sort. Yeah.
So let's assume you're doing a add. So your transaction is going to look like this. So using. Oh, is it still small?
I can zoom in. There we go.
I think we're fine. Yeah. That looks good.
That's great.
Using.
Of all the things we worry about.
And then here you're going to do await, whatever, like, I mean, do you want me to go through like every step literally, like how the code has to be written? Because you have to get a dictionary from the state manager first.
Yeah, you can just talk to those parts.
Okay,
Yeah.
let me just okay. So you have to get a dictionary from the state manager. You query it from the state manager.
Right.
So state manager is just going to be like a dictionary of all the stores present.
Right.
So it's going to be a key value store of all the stores.
Right.
So you query the instance from the state manager, and on the instance that you get from the state manager, then you do the transaction here. So let's assume dictionary 1. And then you specify, I'm not going to the details of the API itself, so just put like key and value. I know that you have to specify like a timeout, cancellation token, all of that stuff.
Sure.
But I'm
Main
not
thing
going
is
to
there's a
that.
key and a value.
Yeah, that's not
Yeah.
that interesting.
Yeah.
That's just
And then you
syntax.
just do commit async. So as soon as you add a key and a value in the dictionary, let me go through just the primary part. I think that will make a lot of things simple.
Sounds good.
And for if I swallow any detail just to make it simple, then I'll let you know that things might not be precise there. When you go into the different layers, then that
then
will
we
be
can
taken
discuss.
care of. Yeah.
Sounds good. Thank you.
So when you add a key and a value, so what happens is, so the user, we get the key and value, and first we build a write set onto the side. In the code, this translates literally as write set. There is a file for writeset.cs. That's what it's called translate to.
Sweet.
So this is going to be, we'll have a data structures sitting here, one per every transaction. So basically, these write sets track any things that are in flight. Okay, I'm not going to go into the details of the data structure itself. Let's just assume it's a write
this.
set.
Yeah. Sure.
So in the beginning, you're going to put like the key and value will go in here. But even before we go in there, we do support pessimistic rise, which means we take logs
Okay.
upfront. So when you do a key and a value, it goes through acquisition of key log.
Okay.
They're all granular logs, row level logs. So we go, in fact, the very first is actually overall dictionary level log, just a read log, to make sure that nobody is deleting the dictionary behind your back.
Okay.
So it's just a read log. That happens for every operation. And then we do a specific key level log just for this key, this row, key and value. And if all of those go through, then that gets added into the write set here. And so this is like only on the primary code path. So it goes into the write set, and of course we will have to replicate now. So when we replicate, we need the bytes. So we will call the serializer, be it the serializer specified by the user or the default serializer, which is the data context serializer.
Sure.
We'll call those, and then this will get replicated. This data is going to get replicated. So here, as a part of this step, we wait for the replicate operation to be accepted. What does acceptance of replicate operation mean? That is something the replicator layer will go into in deep.
Sounds good.
So for now, let's just assume that we just wait for the replication operation to be accepted. So it does not mean we wait for when they're accepting this for replication operation, they also have to make sure that it gets flushed in the log.
Okay.
Okay. So they'll give you the order in which it gets flushed and then logged. But for now, let's assume that we've already given it to them, and they're going to queue it up for replication and for flushing.
Okay.
The log is going to take care of that. So after the replication happens, I mean, I'm not covering all the steps here.
That's fine.
So I'm just like talking to it.
Yeah.
So after the replication happens, then what happens is you come and call command. You could call like so many other operations of the same kind, add async, update async.
Sure.
Then it's going to do the same thing for all, and all the changes will go into the same write set. So if you're going to do multiple, then it's going to go like this.
Okay, dude. Yeah, sure.
So, and the keys and values that and along with some metadata that I'm going to put in.
Yeah.
And each of these entries would be captured as logical operations in the sense, say for example, you're doing an add and then an update of the same key.
Yeah.
Then, here it's going to be overwritten because I know that
They're
the
the
add
same
is no
key.
longer valid.
Right.
But we always have metadata to capture if it's an insert item or if it's an update item or if it's a deleted item. So it's basically logical.
Sure.
After then we submit it for replication and logging, and then the user comes and calls await commit async.
Yeah.
So when commit async, so we still hold the logs are still valid. And when commit async, then they'll have, this commit async goes directly to the replicator. It does not go through the store.
Okay.
So again, this also goes through the same process of replication and getting flushed in the log and all that stuff. And after it gets flushed in the log, then on the primary, they're going to call an API call apply on the backing store.
Okay.
And that makes sure that it moves all these into a permanent data structure. Permanent in the sense, it's no longer in flight.
Okay.
So these are being committed, that's what it means.
Right.
So once it goes here means the user data has been committed.
Right.
It's still in memory, but it's there in the log.
Right.
So it's in here and the write ahead log as well, which is the transactional log that will get covered in the replicator
Yeah.
section. So it goes in there. And after that, after it finishes that for all of the operations in the transaction, whatever you might have here, and then the replicator also would come and say, release all the logs that you've acquired for this transaction. And then the backing store just goes and releases all the logs that was acquired, whatever was acquired in here.
For this set, yeah.
Yeah, the whole set. And and then you finally unlock the transaction. So in case you didn't commit or you chose to abort or you did not even do anything here and then just disposed it, then that is when the logs are going to get released. In the case where the replicator is not even involved.
Cool.
Like in this case, we successfully submitted, but things could fail
Yeah.
after we acquired the log. So for those, this when you dispose the transaction, we'll make sure that all the resources are released.
Wow, that's quite a bit of info.
Mm-hmm.
Yeah.
Okay, so this is the write code path.
Right.
And so this is the in-memory data structure that we put in.
Okay.
So I can go into the other data structures and how we do background operations and all that stuff.
So the
But I'm not
question I
sure.
have is, so
Yeah.
the in-memory data structure, that's on the primary.
So, I didn't even go to the secondary code.
Yeah.
Good thing, good point. So this is only on the primary write set,
Mm-hmm.
because primary is the only one who gets the operation in the
Correct.
beginning.
Correct.
The secondary does not even see it. But when I said that the primary submits for replication and logging to the logging replicator,
Mm-hmm.
there on the secondary as well, it goes and logs it first. And just like how in the primary, after logging, it calls apply on the backing store, on the
Yes.
primary backing store. The same thing happens on the secondary as well. So there it calls apply, and this data structure is present in all the replicas. So that will get loaded into this data structure.
Great.
All the committed data will be in this data structure.
So by the time the transaction log stuff is done, the replicator log stuff is done, all the replicas have been updated to have the same
Correct.
information.
Correct,
Okay.
correct, correct.
Cool.
So as soon as they log, they log on the secondaries, then we can return back to the user saying that data has been committed, independent of whether this data structure on the secondary replicas is populated or not, because it's persisted anyway.
Right.
So they'll be able to replay it from there to load these. So this is what I'm saying. Once we act back saying it's committed, the primary should
Have the
be able to
info.
return back on
Right.
reads, but the secondary might not have gotten it yet because we wait only for a quorum of replicas to act. And after apply is where it's going to be in the data structures.
Yeah.
Things like
So how long so obviously the point of all of this is to obfuscate the fact that it is a distributed system. And what I mean by that, so when I'm programming, I'm thinking about one thing. I'm not thinking about secondaries. I'm not thinking about replicas. I'm not thinking about quorums. So what is the timing that I need to be concerned about? You just mentioned that there could be an off.
So as long as if you want to be I don't want to understand too much, I want to play safe, then don't even try reading from secondaries. Just read it from primaries. You're going to write only to the primary and read it only from the primary.
But what do you recommend for developers? Why would I read from the secondary?
So that completely depends. Like there are a lot of applications where they are okay. I'm okay if I get stale data, I mean, in the sense I'm not going to get the latest read, and I can tolerate if I get something that could be rolled back. I can tolerate that amount of inconsistency on secondary. Sure, go for it. And you do it. The benefit you get is, of course, you're going to be able to read from more replicas now. So you're not just loading the primary with more reads and write requests.
Of course, so you could scale.
Yeah.
So I guess the question would be, how long does it take for replication to occur? 4 seconds?
Yeah,
Like
so
what-
that is the thing. Like I can't really give a number like that.
Okay.
I mean, I don't know if like Sumuk has numbers for different VMs and like standard
Well, we'll
numbers.
be talking to him soon, so we might be able to
Yeah,
plug
so
into that.
but the other thing is it's going to be completely dependent on the infrastructure
Right.
and
Okay.
other factors. So
Sure. Okay, just something for people to think about.
Yeah.
That's
That's
kind of
interesting though,
important.
yeah. So there are advantages where you could consider calling the secondary because you're not doing any reading logs, you're not setting yourself up to effectively have to serialize all your transactions in the same place because you're able to do your reads from your secondary, so your primary can continue to do writes per se,
Correct.
right? Okay.
So the other thing with reading logs that you mentioned is for repeatable read we take logs, but
Okay.
for snapshot we don't.
We don't.
And on secondaries we only expose snapshot reads. Because we don't want the logs conflicting on the secondary, because primary is the only one that deals with read and write logs.
Right.
Secondary just faithfully replays whatever the primary order is. So we don't want a conflicting log being taken on the secondary. So
Right.
we expose reads only as snapshots.
So could I ask you to draw us a little diagram of the different components then sort of, so you have
Sure.
the reliable state manager at the top that you sort of alluded to a few times, and we'll go into some more depth with that in oncoming videos. The goal is sort of to go through all of these components, but now that we have Preetha here with us, sort of at least get a high level architecture, then from there we can start to delve deeper into a few of these things. So you're the reliable state manager, and then,
So we should have a reliable dictionary as well.
sure.
iReliable or like
Yeah,
whatever that.
Does anybody ever say iReliable dictionary out loud? Other than me?
I think everybody calls it reliable dictionary.
Yeah.
So the reliable dictionary sits on top of the store. Store. And then here, reliable state manager is kind of, it's just an interface. It kind of sits on, it covers some of the APIs from state manager.
Okay.
And I think we call it transactional replicator now. But if so just from the like in-depth layers, ignoring the interfaces and all that stuff, if you see, it is going to be T-store who is going to get the actual requests,
Yeah.
like add or read.
Yeah.
The public-facing API is going to translate.
That's
it.
sort of this arrow here.
Array, this
Yeah.
one here, yes. And then this will go into the state manager for submitting for the replication operations.
Yep.
And the applies that it gets as well is also from here to here. So it goes in this direction and then comes back in this direction.
Yes.
as well. So this is going to be the transactional replicator or the logging replicator, let me just call it.
Yeah.
And the internal components are just called that, so let me call that name.
Yeah.
Logging, and then this in turn interacts with the log. So the logging replicator maintains the transactional write-ahead log, and that log is implemented in the log layer.
Okay.
So this is the flow. So if you see replication operation goes through like this, and then on commit, when they come back and say apply or release the logs, then it comes back in this direction.
So taking your example here where we're adding something to a dictionary, so this is dictionary 1 and we're adding KV. So here I know that KV is coming in, here I know it's dictionary 1 because I have a set of all the dictionaries that exist. This goes down and makes sure the primary as well as all the secondaries have KV committed to them. This is the thing that ensures on each of the machines that is actually there.
So this will persist it, and
Yeah.
here it's going to keep it only in memory.
Correct. So this gets persisted on the disk, and this confirms up that yes, all the things are there. This will inform the state manager that that dictionary has been updated.
So this guy takes care of making sure that quorum, it gets a quorum of
responses,
replica acts as
right,
well.
from the replica.
So it's
Okay.
not just about the local one. This is
Correct.
only the local picture.
Correct. Okay, so this would be forked into various,
Yeah. So like all the
each machine
each
basically.
machine after
yeah.
it logs, it says
Yes, I'm
I'm
good.
done.
Each
And
replica.
then this guy goes back.
Right,
and
so
says,
once it has a quorum of replicas, it'll inform the state manager that that dictionary has been updated. And then the D store will be able to say this transaction is now
This
done.
layer itself does not know anything about add or update or what it is. All
Okay.
it knows is I got
Something's
something
happened.
for application.
I see.
Give it back to this store.
And is that conveyed through the metadata that we discussed here?
Correct,
or?
correct.
Okay, all right.
So
cool.
each individual collection basically makes sure that it gives the information that it can translate back to, and that is just given back by the login applicator.
Sweet.
And here it's only one store, so of course you can have multiple ones as well.
So how would that work? How would you have multiple? So that's if multiple transactions are coming in at the same time. Or
No, this is not multiple transactions. This is multiple stores.
of transactions.
Uh,
How?
so you can have. So here I gave dictionary 1, right?
Right.
You can have like 3 dictionaries.
Sure.
I don't know. One you can maintain the data. One you maintain metadata
so
about
for
something.
each dictionary, we have a T store.
A T store, backing
Okay.
T store. And you can do a transaction across all those.
Right.
So from these layers, again, so this layer and this layer does not really care if these 2 layers don't care whether you're giving it from a single dictionary or multiple dictionaries. It doesn't care. I got the data that I have to replicate. I have to make sure I persist it in the log. And then I'll have to be transactionally
Interesting.
consistent. So this layer is the one that translates
The incoming.
incoming one. So
Yeah.
this knows that which store gave it, and then when it comes back, it has to again give it back to the corresponding.
So this is the only thing itself that's only one entity then in the cluster, because these scale based on the number of replicas that there are. This one exists for
No,
each of.
this is the whole thing is one in each replica.
Oh, okay. So
The
the
whole
entire
thing,
thing exists across, and then this would be the number of literally the reliable collections that you have, because each one is backed by the
Correct,
D store.
So this, like I said, it's a literally a key value store
Right.
of stores.
Of all the D stores.
So basically,
correct.
it'll have store 1, store 2, or
I see.
and if it's a different collection, then basically it'll have that.
That cleared up the picture a lot. Thank you.
Yeah.
Super useful. Yeah, awesome. So some more, I guess, fun contact spots now that we're done some whiteboarding. So how did you end up working on this? And I mean, you can take a seat if you'd like.
So I've not covered the things in the background, but I assume this is good enough to start.
Yeah. And I mean, we have you in case we need to go into more depth in the future as well. Yeah.
So I started in this team 4 years ago, and I heard about the Reliable Collections project. So and then I reached out to.
Rich, I imagine? Or?
No, not Rich actually. I reached out to the first person actually I reached out. I gave my resume was to Vipul. So Vipul was my hiring manager.
Nice.
And then I said I want to work on this one. And then they made me talk to Mihail and Gopal because those were the guys prototyping at that point.
So you came here to solve a very specific problem.
I came here very
How did
specifically
you
for
know
this.
that that's what you wanted to do? Or where had you encountered it elsewhere?
So before I joined this team, I worked in SQL.
Okay.
I was not really working on the storage part or anything in SQL. I was not anywhere near that.
Yeah.
I was interacting a little bit with Todd and Dan.
Nice.
Because of their previous version of Service Fabric, which was Blackbird. That's how I came to know about what was going on in the team, but I always wanted to work on storage. And this was a brand new project. Like if I were to go do that in SQL, then it's going to be like, it's already established, it's not like anywhere near storage kind of thing. This was brand new, so I really wanted to try like a startup kind of thing.
Yeah.
I can go try things.
That's awesome.
So,
And without divulging any information too much, sort of what do you think are some of the key challenges you're facing today, and where are we sort of headed in improving how the T store works and how we're able to offer reliable collections?
So I think in terms of we will have to. I think in terms the biggest challenge that we'll have definitely is in terms of like usability and improving diagnostics.
Okay.
And helping them able to figure out. So the advantage that we have, it being a stateful service running in the same process as the user application and all that stuff, is really great. So people who really want low latency reads and writes, and they're really looking for perf and those, it's really, really good.
Yeah.
But for others who want to, I mean, because you're kind of co-located in the same process, you'll have to make sure that how do you give SLA guarantees in terms of is their process is the user process taking up more, or is it ours, and things like that. So those are going to be really challenging.
Yeah.
That we have to go figure out how to be able to give kind of guarantees saying,
Yeah.
we'll keep ourselves within this.
That's cool.
So
Hard to
things
say
like
that. Hard. Yeah. Wow. That's interesting though. If we're able to say that within 95% confidence interval or whatever, you can commit this quickly and this
Correct.
fast and access info this quickly.
So I mean, we could still do, but then it's about like how much would you be able to like separate yourself from them and things like that. It's going to be
Right.
hard.
Awesome. Cool.
So,
Do you have any other
Great.
questions?
That's
Chads?
good. I think that's a good introduction to reliable collections.
thank you.
Yeah. All right. Thanks so much for your time, Preetha. Yeah,
Yes.
this is a really useful 30-minute or whatever session ended up
Yep.
being. I learned a bunch. I know people on the other side definitely learned a bunch.
Absolutely.
And really appreciate your time.
Yes.
Looking forward to
Thank
doing
you.
some more of these.
For
now
sure.
that we have a better overview of where we're headed. So just for the folks on the other end, so she gave a great description of some of the different parts of how we are able to deliver reliable collections.
Yep.
And some of the future videos that we'll be doing will sort of dive into those different parts as well, so that you can start to paint the picture of how all these things sort of come together.
Yeah, and finally, maybe we can talk about replicated state machines. And that's what it's all about. Yeah.
Yeah.
All right.
Thank you.
Thank you so much, Preetha.
Thank you.